All right, class, in this lesson, you are going to learn to use one of the few techniques in solving quadratic equations. And in this particular lesson, you're going to learn to use graphs and tables to do so. All right, so let's go ahead and get started with the first example. Okay, so let's say that you are tasked with finding the solution to x squared minus 16 is equal to 0. Okay, well, remember that when we're solving for this, when we say that this function, and when I say this function, this is really the function f of x is equal to x squared minus 16. Okay, when we set that equal to 0, what we're really saying is set y, right? F of x is the y equal to 0. Well, think about where y is equal to 0 on a graph. Okay, so whatever the graph looks like, let's say it's a parabola and it looks like this. Okay, when we set it equal to 0, what we're essentially saying is, where does it intersect the x-axis? Now, how do we know that? How do we know that we're looking to find where the parabola intersects the x-axis? Well, think about all of the points on the x-axis. Okay, pick any point. Let's say -4. Well, what is the coordinate value of that? Well, the coordinate value is -4, 0. Okay, and let's pick another value. Let's say this one right here, 8 on the x-axis. This coordinate here is really 8, 0. Now take a look at the y component of the coordinate. Okay, here we have -4, 0. My y component is right here. That's 0. Okay, the y is 0. So let me just go and label this. This is x, y, and over here at 8, 0, this is x, y. So we're essentially saying that when the parabola intersects the x-axis, and let's say it intersects at -4, 0, what we're saying is that the function, or y, is equal to 0. Okay, over here, the function, or y, right? When I say or, what I'm saying is we could call it f of x or we could call it y. They're the same thing. They're synonymous. This y is equal to 0. So when we go back to the original question, x squared minus 16, and it's asking us to set it equal to 0 and solve for x, what we're essentially saying is, where does the parabola intersect the x-axis? Because if it does intersect the x-axis, then I know that wherever it intersects the x-axis, my y is 0, which is exactly what we're looking for here. Okay, so there are two ways to do this. To graph the function here, or this parabola. Okay, the most rudimentary or the most basic way is to create this chart. Pick some x values, and I've picked, obviously I know what this graph looks like, but if you don't know what it looks like, you want to pick some random x values, and then what you're going to do is just plug them into the equation. Okay, plug them in here, right? And then you're going to get some sort of value, and that value is going to be your f of x. So we're going to put that over here. So let me go ahead and delete this to get that out of the way. And let's go through the steps here. So let's say we're going to take -4 and we're going to plug it into this equation. Well, -4 squared is equal to 16. Okay, so I'm going to say f of -4 is going to be equal to -4 squared minus 16. Now, for those of you who are entering this into the calculator, you need to be careful to, when you enter -4 squared, that you put them in parentheses. Okay, when you put them in parentheses, what the calculator will do is square -4. If you don't have the parentheses in its place, okay, it's going to take 4 squared and then negate the final value. So you have to make sure that you include the negative in your parentheses. Otherwise, the calculator is going to give you the wrong answer. Okay. All right, so -4 squared is 16, and 16 minus 16 is equal to 0. Okay, so we know at -4, my y is going to be 0. All right, So let's go ahead and put in an x value of -2. So f of -2 is equal to -2 squared minus 16. And -2 squared is 4. 4 minus 16 gives us -12. Okay, so at -2, we know it's going to be -12. And let's go ahead and do select x equal to 0, which is the next point, and plug that into the equation. 0 squared minus 16 is basically -16. Okay, and then f of 2 is going to be 2 squared minus 16, which gives us -12. And then f of 4 is going to be 4 squared minus 16, which is going to be 0. Okay, now we're going to go ahead and plot those points, and I need to erase this and move these out of the way, and I apologize for that, but hopefully you've got an understanding of what I did there. And let's go ahead and plot these points. Okay, so the first one is at -4, 0. So we're going to plot a point at -4, 0, which lands me right here. The next point is -2, 12. -2, 12 is -2, 12, which lands me right there. I'm sorry, -2, -12. I missed the negative. So that puts me right down here. And then my next point is at 0, -16. All right. So at 0, -16 puts me right over here. And then 2, -12 puts me right over here. And then my last point, 4, 0, which puts me right here. Okay. So if you were to graph this parabola, all right, we see that the graph intersects the x-axis at -4, 0 and at 4, 0. Okay, so our solution here then would be x is equal to -4, okay, or x is equal to 4. So both those x values make this function equal to 0. Okay, so I had mentioned that there are two ways to do this. One, which is what we did, the rudimentary way, takes a little bit of time, but if you just plugged in some x values, you can get some y values, plot those points, and you can get an idea of what that graph looks like. Okay, the second way, which is a lot easier, is use a graphing calculator like Desmos. And when you use Desmos, all you need to do is plug in the function into the calculator, and that function here would be f of x is equal to x squared minus 16. You plug that in and it'll graph it for you, and you can visually take a look at the graph and see where it intersects the x-axis, and you'll see that when you plug that into the calculator, it'll give you a graph that looks just like this. Okay, so that is the most basic way of solving for a quadratic function when it's set equal to 0. Okay, so this is called by graphing. Now there are two other variations I wanted to make you aware of, and I'm going to go ahead to the next example and show you what I mean by this. Okay, so I'm going to go ahead and do it the rudimentary way of solving for this function. And remember, this function is going to be f of x is equal to x squared minus 14x plus 49. Okay, now as I mentioned to you before, you can go ahead and plug this into Desmos calculator and it'll graph it for you, but I'm going to do it the rudimentary way, and I won't go through every single calculation because I've already demonstrated that in the prior example. Okay, but if you plug in 3 into this function, you would get a value of 16, and then if you plugged in 5 into this function, in this function, you would get 4, and if you plugged in 7 into this function, you would get 0, and then if you plugged in 9 into this function, you would get a value of 4. And then lastly, if you plugged in the value of 11 for x into this function, you would get a value of 16. Now, if we went ahead and plotted those, let's take a look at what happens. 316 lands us somewhere up in this area. Okay, so let's see, 9, 10, 11, 12, 9, 10, 11, 12, 13. Basically, it's off the charts, okay? So we're not going to plot that. However, we can go ahead and plot the next point, 5, 4. So 5, 4 puts us right there. So we can go ahead and plot a point here. And then the next point is 7, 0. Next point is 9, 4. Okay, and then the last point is 11, 16, which is off the chart. But you can get the basic idea that this parabola looks something like this. Okay. All right. So in this example, what we notice is that the parabola intersects the x-axis only at one point, which is 7, 0. Okay, so our only solution here for this equation is x is equal to 7. Okay. Now the point I wanted to make here is that unlike the prior example, over here we had two solutions. Okay. In this example, we only have one solution. Okay. So when you're solving for a quadratic equation that's set equal to 0, it doesn't always mean that you're going to result in two answers. Sometimes it will be one. It just depends on the function. Okay. And then the next example would be the third variation. Here we have x squared plus 3x plus 7. And let me go ahead and write the function. Function is just equal to x squared plus 3x plus 7. Okay. Now I've purposely selected these x values, and you've plugged each one of these in to this function. Let's say we plugged in -3 in here. We would get a value of 7 for my f of x, or y. If you plug in -2 into this function, that would result in a value of 5 for my f of x. And if we were to continue with -1, we would get a value of 5. Plugging in 0 into this function gives me a value of 7. And last but not least, value of 1 into this function gives us a value of 11. Okay, now plotting those points, we would see that our first point is going to be at -3, 7, which puts us right there. The next point would be -2, 5. That places us here. Then the next one is -1, 5. That places us here. The next point is 0, 7, which places us up. Actually, that should be 2, 7. Something's off here. Should be 2. If I plugged in a value of 2, we should get a point over here. There should be 2, 7, not 0, 7. Let me go ahead and correct that. And then the next point should be at, actually we don't even need the next point. My apologies. Okay, so if you notice this, what we've plotted so far, okay, we kind of see a parabola, but we don't know exactly where the vertex is. Okay, now using the graphing calculator, it'll obviously tell you where the vertex is, but if you recall from an earlier lesson, we can actually solve for the vertex. Well, how do we do that? Well, if we find the axis of symmetry, right, my axis of symmetry, that equation is my x value, which is also the x value of my vertex, that equation is negative b over 2a. Okay, so if we insert those values, well, my b here is 3, and so we're going to have a negative 3 over 2a. Well, a is 1 because the implied coefficient in front of this x is 1, and so we're going to have 2. We see that my x value is negative 1.5. Well, at negative 1.5, that places us right over here. Okay, negative 1.5. And it looks like everything's kind of shifted in the wrong direction. Looks like I've made several mistakes here. Let's go through the calculations here and see where we went wrong. If we enter negative 3 in here, this gives us 9, and then 9 plus 3 times negative 3, which is also negative 9. That gives us a value of the sum of 9 minus 9 gives us 0. That puts us at 7, so that is correct. Negative 2, if we enter that in, that gives us a value of 4. 4 minus 6 is negative 2. Negative 2 plus 7 gives us a value of 5. So we are plotting these correctly. Let's see. Negative 1. Where does negative 1 place us? Negative 1 squared is 1. 1 plus 3 times negative 1 gives us negative 3. So 1 minus 3 gives us negative 2. And negative 2 plus 7 gives us a value of 5. So I guess I was right before I corrected this. So this is really, let me go ahead and correct these points here. At 0, we're going to have, or I'm sorry, negative 1 is going to be at 5. Okay, and then I think I had earlier, this value was 0. Go ahead and correct that. And so at 0, it should be at 7. We have 0, comma 7. All right, so this looks more correct. So I had it right before, and I apologize for taking us on a slight detour here. All right, so let's go ahead and go back to our axis of symmetry, negative 1.5. That puts us right here. Okay, so we know that our axis of symmetry is cutting this parabola in half, so we know this is correct. And so to get my actual coordinate here, we need to figure out our y. Well, how do we do that? We're going to plug that into the function. We're going to plug this x value into this function. Okay, so f of negative 1.5 is going to be equal to negative 1.5 squared plus 3 times negative 1.5, okay, plus 7. And that's going to give us, let's see, 2.25 plus negative 4.5 plus 7. Okay, and if we add those up, 2.25 minus 4.5 is going to give us negative 2.5, and we add 7, and that's going to give us 4.5. Okay, so what this is telling me is that my vertex is going to be at negative 1.5, comma 4.5. So if we went ahead and plotted those, negative 1.5 is going to be right about here, and then negative or positive 4.5 lands us right there. Okay, so we can plot a point here, and then what we see is our parabola looks something like this. Okay, all right, so we basically went through all that trouble to draw or graph this parabola, and what we notice is that this parabola does not intersect the x-axis. Okay, so in this case we would say that the answer to this, this equation is no solution. No solutions. Okay, And there are no solutions because this parabola does not intersect this axis. And just to clarify, I want to be a little bit more accurate. There are no solutions in the real number world, okay? And that's the world that we're operating today. But if we were to solve this and include the imaginary number world, then we would have a solution. Okay, let's go ahead and move on to the next example. And so these three examples that I've shared with you so far are ways to find the solution of a function equal to 0 by graphing, okay? And so just to summarize, if we do it by graphing, we saw that you could have two solutions, you could have one solution, or you could have no solutions. All right, now the second method of finding the solution to a quadratic equation is by chart method, okay? Meaning, we did this already 3 times, but if you take a look at a given chart, let's say that in a problem they give you these coordinates, okay? Well, how would you find the solution to x? Well, it's very simple. All you need to do is look down this column and see where it is equal to 0, okay? And its associated x becomes your solution. So we have two solutions here. We have a 0 here, which gives us an x of 1, and a 0 here, which gives us an x of 6. And so our solution here would be x is equal to 1 or x is equal to 6. Okay? So this is probably the simplest way to find the solution to a function equal to 0 when a chart is given to you. Okay, I hope that made sense, and again, I apologize for that slight detour there, but hopefully that kind of gives you an idea of what typically can happen if you're making a mistake, and so you got to see that in action. In any case, if you were not clear on how I did any of this, please go back to the beginning of the recording and listen to it again. Thank you.